How is it that a failing star, which does not actually produce any light, still emits light signals? The James Webb Space Telescope has just solved this mystery. The telescope detected infrared light, which would barely be apparent in our world without special technology. In another aspect, however, the star could be a sun shining with mysterious energy. Brown dwarfs are very unusual objects in the universe. They are also called failed stars. They have some properties of a star but do not have the necessary mass to trigger the nuclear fusion of hydrogen into helium, which is required to produce light and heat. Brown dwarfs are formed by the collapse of gas and dust clouds, just like real stars or luminous stars, except they do not begin to shine like conventional suns. After the process, brown dwarfs share many properties with other stars. They have a spherical shape and a hot surface. When they form, the mass of a brown dwarf is usually between about 13 and 80 times the mass of Jupiter. This mass is insufficient to generate the pressure and temperature needed in the core to start hydrogen fusion. However, during their early development stage, brown dwarfs can fuse deuterium, a heavy isotope of hydrogen, which can also fuse at lower temperatures. However, deuterium reserves are rare, so this fusion process lasts only for a very short time. Stars that can trigger full hydrogen fusion enter the so-called main sequence stage, during which they shine stably for billions of years. Brown dwarfs do not reach this stage, and thus lack the energy source that hydrogen fusion provides. Brown dwarfs cool over time and become weaker, emitting a mysterious glow. The James Webb Space Telescope has now succeeded in tracking it. The Webb telescope detects light in a completely different bandwidth than the Hubble telescope or other comparable observatories. Webb captures infrared signals and analyzes its waves using 4 special spectrometers. Brown dwarfs have revealed their mysterious glow in the infrared range. In the pursuit of this strange glow, the brown dwarf was previously placed in an intermediate position in the universe. Researchers saw it as something between large gas planets and small stars. This situation was mainly attributed to their size and gravity. However, brown dwarfs could form their own category of celestial objects that we had not recognized until now. The James Webb Space Telescope discovered an aurora around a brown dwarf located more than 40 light-years from Earth. This discovery, called W1935, is special not only because the brown dwarf is luminous but also because it is close to other stars. Normally, brown dwarfs appear isolated. At first, it was thought that W1935 might reflect the light of nearby stars, but the JWST found methane emissions on W1935. Methane could produce the aurora. The emissions would also be characteristic of the heating of the atmosphere, with charged particles traveling along magnetic field lines and colliding with atmospheric particles. The energy likely comes from inside the brown dwarf. Another theory suggests that interstellar plasma might crash into W1935 and trigger the aurora. Interstellar plasma contains far fewer particles than the plasma emitted by stars, yet the particle density might be enough to explain the mysterious glow around the brown dwarf. The density of plasma in free space is probably not the same everywhere. It could be higher near many neighboring stars. If the brown dwarf were traveling through a region of space where the plasma density is high, this could lead to a glow in the infrared spectrum. It is also assumed that the brown dwarf might not be alone. It could be receiving particles from a nearby dynamic moon or another celestial body. It is possible that we have not yet discovered this object, but with the JWST, we have a good chance of solving the mystery. A small moon would likely be too modest to be detected by the spectrometers, but if it were another object the size of a planet, Webb could theoretically detect it. Brown dwarfs are not rare in space. In fact, they are quite common and make up a large part of the stellar population of small size. At first glance, they may seem useless, which is why researchers have given them the nickname failed stars. However, we may have overlooked the fact that this type of star shines in a different class of light and could belong to a world of dark objects that we have not been able to see and study before. Is there a dark universe? While we are quite familiar with the luminous universe filled with light, the dark universe remains a largely unexplored domain. Darkness, dark matter, dark energy, and interstellar space constitute a large part of the entire universe. It is precisely here that we may also find answers to all the phenomena and circumstances that we have not yet found in the world of visible phenomena. For example, we do not even know exactly how matter was created, nor do we understand the dynamics that contributed to the creation and development of the universe. This is precisely why researchers have hypothesized the existence of dark matter and dark energy. Although we cannot see or measure them, we can observe their effects. Dark matter is a fundamental component of the matrix of our universe, and dark energy is a kind of fuel. In addition to these two elements, there are other dark objects, such as brown dwarfs and black holes. This phenomenon, and the fact that nothing happens by chance in the universe, has led researchers to the idea of a universe that exists right under our noses, in parallel with our world, the dark world. We live in it, and it lives with us, creating our visible structures. As for black holes, we only know they are there because they exert a force, and we can at least track them a little. We now know that brown dwarfs emit light, but not in the spectrum that is normally visible to us. Our technological capabilities are improving, and we may soon be able to understand this dark universe. Some researchers even argue that we must understand this mysterious dark aspect to better explain our own visible world. From the dark universe to the parallel universe, you may be surprised to learn that not only is there a dark world within another, but there are likely one or more other hidden worlds in the darkness, made up of particles. This means that there are huge empty spaces between the tiny elementary particles. This is also how researchers came up with the idea that matter is not as solid or material as we once thought. In fact, matter is essentially nothing. In the particle accelerator in Geneva, researchers conducted a series of experiments in the subatomic field and discovered particles that are even smaller and behave in increasingly strange ways. Less than 100 years ago, an atom was considered microscopic. Today, we know that atoms are made of many smaller building blocks. Electrons, neutrons, protons, quarks, and bosons are just a few of these particles. To discover the true purpose of our universe and its workings, researchers are looking for clues in the subatomic world. One logical way to solve the mysteries of the material world is to break down matter, but this hasn't worked as well as researchers had hoped. They have reached a threshold where particles behave in such a way that they defy measurement according to our old rules. The German physicist Werner Heisenberg saw this threshold less than 100 years ago, and it was named the Heisenberg uncertainty principle in his honor. Today, quantum physicists assume that beyond this threshold, in the world of the void and darkness, we are likely to have reached the fundamental level of the matrix. It seems that the magical point of the Heisenberg uncertainty principle is a key to understanding the true nature of the universe now, whether it is a brown hatred of a bright sun, a flower, or the human body. All are made of matter. Within this matter, there is always the threshold of Heisenberg, the darkness. There is a change towards other possible aspects. This means neither more nor less than thresholds towards other aspects exist even within you. This quickly shows how little we understand our universe and our matter. We probably know very little about ourselves, our computing, and our possibilities. When we observe and analyze brown stars with our advanced telescopes like the James Webb, we are only scratching the surface. Despite our very advanced innovations, we are still far from truly understanding what stars and our universe are in their multidimensionality and in the global cosmic scene. Perhaps one day we will understand, when we have new innovations or when our inner voice has significantly expanded. Phenomena such as brown stars that shine with the appearance of red light could hold more insider information, and their presence as stars apparently blocked might have a deeper implication than we realize. It is entirely possible that these dwarfs, which only shine faintly in red, are actually true suns shining in another aspect. Other worlds might even need this light just as much as we benefit from the light of the sun, basing all our computing on it. What is the compatibility between the lights of cold stars and quanta? Let's examine the dark stars at the level of quanta. Quanta are particles of light, carriers of information, and they are fundamental building blocks of reality. All contacts have a form of energy that they generate or emit. Essentially, they are also light, unadulterated, but this light is so microscopic and delicate that we cannot see it with our human eyes. No one has ever seen a quanta with their own eyes. Even atoms are actually invisible. We only know these particles exist because we have detected them experimentally and can study their behavior and effects. Nevertheless, this means that all matter is, in fact, made of pale light. Even brown dwarfs and apparently dark stars are therefore luminous objects in other aspects, close to or beyond the blur of worlds of pale light. Mythical worlds, divine aspects, or simply other universes could exist. This discovery is consistent with string theory, which posits that there are at least other aspects beyond our four aspects, and these aspects are around us, except we cannot see them. Subscribe to the channel now to see more exciting videos.